Hi everyone. Hello. Hi guys. Welcome back to Vedantu's JEE channel. How are you all? All my 12th standard students who are aspiring for JEE 2021. I welcome you all because this is specifically the day and the time when we meet to discuss MCQs related to the current topic which is ongoing for your preparation of JEE 2021. So guys, today is the time when we are going to discuss MCQs based upon the topic that we studied in the previous session, that is Kirchhoff's laws. And all my students who have not attended those sessions, I will tell you towards the end how can you cover up all the topics as well. Okay. So I welcome once again everyone. I'm sure that all of you are excited, especially for people who are new on this channel. Let me start off with my introduction. Yes, guys, this is me, your Suri Sir. I'm an alumnus of IIT Bombay, and nowadays I am known as Mugambo. Yes, that's my YouTube avatar. Why am I called that? Is because when you will crack this examination of JEE, Mugambo Khush Hoga. And yes, you all will do very good in the next year's JEE examination. Okay, cool. Also, guys, if you are not aware about it, then let me also tell you the schedule, the daily schedule that we follow for aspirants of JEE 2021. So, guys, every day at 9 p.m. we meet for theory discussion. Yeah, and on selected days like today we meet for MCQs discussion. Okay, so on Monday, Wednesday and Thursday, on Monday, Wednesday and Thursday we meet for MCQs discussion, but every day at 9 o'clock we meet for the theory discussion of physics, chemistry and maths related to your JEE preparation. Okay, and also this is the set of teachers who are going to be with you guys for your JEE preparation for next 1 year at least. Okay, and let me introduce you all to them. This is Harsh sir. He teaches you all chemistry. This is Arvind sir. He is your mathematics teacher. And now you know me. This is me, your Suri Sir. I try to teach you all physics. Okay. Also, guys, if you are new to the channel, then definitely subscribe right now. Press the bell icon so that whenever your Suri Sir comes live, Harsh Sir comes live, or Arvind Sir comes live, you will be notified about that. Okay. Cool. Awesome. Also, guys, if you are not aware about it, you should know that Vedantu has its own platform where we teach students, and not just we teach them, those all of you who are preparing for JEE or NEET examination, there are regular lectures which happen every day for you guys on Vedantu's platform itself. There you don't just get the learning or in terms of the teaching from our end, you also get to attempt a lot of tests. The test series is for all yours. You have a lot of doubt sessions going on. It's more like a hand holding, which is to a next level than what you get on the YouTube channel here. So if you are interested in something like that, then let me introduce you to the Vedantu Pro subscription plan. Okay, or for that, by the way, the informations even more in detail are available on this link, and also the enrollment is possible by clicking on this link. That link is obviously available in the description box of this video, and when you are going to click on that, you will have to select your standard. I'm assuming you are a 12th standard student, so you will accordingly select the examination for you. That will be JEE Main 2021. Okay, also, what exactly are you going to get? As I said, you are going to get live interactive classes, assignments and notes, that means study material, and test, and your own analysis is going to be given, and the areas of improvements will be shared, and hand holding will be done by your very own master teachers. Okay, let me just give you a brief. What exactly do you get in terms of the curriculum? You're going to get around 40,000 plus hours of live teaching. Yes, I'm not talking about recorded lectures, I'm talking about live teaching is what you're going to get. You're going to have 20 plus teachers with a lot of experience to teach you during your JEE preparation. Okay, also a lot of testing and assignments for you. You have the benefit of choosing your own language, whether it is Hindi or English that you are comfortable with. As I said, continuous review as well as suggestions from our end to tell you what are your areas of improvement, what should you work upon, and unlimited access to micro and crash courses of Vedantu. By the way, this is how the platform looks like. This is Pulkit sir teaching. This is the chat box where students can ask their or rather communicate here, and then there is a Q&A panel where you can ask your doubts as well, and this is where the teacher is explaining a concept. Okay, it's an amazing platform. We call it Wave. Okay, So guys, how exactly can you enroll for this? There are multiple type of subscriptions possible. You can go for monthly, quarterly, half yearly or annual subscription, okay, based upon your own uh, you know feasibility and your requirement. So all you have to do is select one of the subscription plan and just go and click on enrollment. Also, there is a good news that if you basically subscribe right now, you will be able to avail 15% additional discount. And how will that be possible is by using this coupon code, that is SMPRO. Okay, so use this coupon code when you're going there. You will have additional 15% discount on any of the subscription that you're going to take. For that, all you have to do is use this link, which is available, again I'm telling you, in the description box of this video. Okay guys, cool. I hope it's understandable to all of you. Awesome. So guys, now let's get back to the session for the day, and that is Kirchoff's laws quiz. Okay, so guys, if you were there in my previous session, you know that there are total two laws that we studied in our previous session. One is called KCL, also known as Junction Rule. Okay, it's all about current, and other one was KVL, which is also known as Loop Rule, which is all about the voltage value. So it is said that at a junction, the net value of the incoming current will be equal to the total value of the outgoing current, or you can say the net algebraic sum of all the currents at a junction will be equal to 0. And if I say about KVL, for KVL the net value of, or you can say the algebraic sum of all the voltages in a given loop in a circuit will always be equal to 0. Okay, so let's go ahead and solve the problems here. Try to solve questions along with me and keep on sending your answers. Okay, so guys, the very first question, this says that the value of current I in the figure shown is to be found. This is the unknown current that we have to find out. So let's start with different junction. This is the very first junction that I come across. Okay, so let's call this junction as P. On this junction, what you see that 10 ampere current comes, and out of that 10 ampere current, 6 ampere has gone to the other junction. Let's call that junction as Q, let's call this junction as R, and let's call this junction as S. Okay, so from P to Q, 6 ampere has gone, so remaining is your 4 ampere current, which will go from P to S. Now when we look at junction S, you have 4 ampere current reaching. Out of that, 1 ampere is going somewhere in the circuit, so definitely the remaining 3 ampere will reach R. Okay, now if we talk about junction Q, you have 6 ampere and 2 ampere as the incoming current, so definitely your 8 ampere current has to be the outgoing current from junction Q. Now finally when we reach at junction R, you have 3 ampere and 8 ampere, two currents reaching the junction, so overall 8 plus 3, your final answer has to be 11 ampere, which means answer is option A. Okay guys, a warm-up question. I'm sure all of you were able to get this answer along with me, in fact much faster than me as well. Okay, cool. Let's move on to the next one. Now this question says guys that the potential difference between point A and B is to be found. You know that if this point is A, then this is also A, and this point is B, so we have to find out VA minus VB. Already the direction of current has been given, so definitely current, whenever it passes through a resistor, it always goes from higher to lower potential or creates a potential loss. Okay, so if I start moving from point A and I'll start going towards the right side from A to B, then what we are going to see that first comes the battery, on which I'm moving from higher to lower potential, which means it's a potential drop of 6 volts, so I'll write it as minus 6. Then I go on this resistor from minus to plus, which means lower to higher potential, so it will be an increment of IR, that is 2 into 3. After that, we come across the battery, where I'm going from again higher to lower potential. That means it's again a potential drop of 9 volts, and then again from negative to positive, which means it's a potential increment of IR. So that is 3 into 3 ampere. So like that, I'll be able to reach to potential of B. So what do I have here is VA minus 6 plus 6 minus 9 plus 9 is equal to VB, which means what? Everything gets cancelled apart from VA and VB. It says that VA is equal to VB. That means there is no potential difference between them. I can say that VA minus VB is equal to 0. That means our correct answer to this question is option D. Okay guys, cool. Okay, now coming to this loop, we have to find out the value of the unknown EMF E over here. So what I'll do first, guys, I'll rather give the three corners over here as subnames. Say this is A, this is B, and this is C. And say I'm going to move anti-clockwise in this loop that we see here as A, B, C, A. And as the direction of currents have been given, so accordingly I'll mention the polarities of the potential drops. Okay, so you can see that I have all the polarities being mentioned, and I'll start moving from A to B to C to A. So A, B, C, A is the loop in which I'm going. When I go from A to B, first I come across this battery whose potential is unknown, and I'm moving from higher to lower potential. That means it's a potential drop of minus E. After that, I go from negative to positive. That means a potential increment of IR. So it is plus 1 into 4, that is IR. After that, I reach point B. From there, when I'm moving from B to C, again I come across a negative to positive increment. That simply means it's a positive, it's a potential increment of I into R, that is 1 into 6. Okay, it's the same current that is flowing throughout. Okay, and also a battery whose potential is dropping when I'm moving across it. So it's a minus 5 volts potential drop that I have. From point C, now I am going to move to A. So again, this time I'm moving from minus to plus. That's a potential increment of 10 volts. Okay, guys. Then I'm going from minus to plus again. So it's a potential increment of 3 volts. And what else do I have? Is nothing else. I can say that this all potential value is 0. So drop of potential, increment of potential, this is increment of potential, drop of potential, increment, and further increment. So E goes to the other side, becomes positive, and here we have 4 plus 6 minus 5 plus 10 plus 3, which means I have 10 plus 10 plus 3, that is 23 minus 5. So the value of E comes out to be 18 volts. I hope you guys have got the answer along with me. Answer comes out to be option B. Okay, cool, guys. Be careful when you are moving in the loop. Whenever you are moving from plus to minus, remember that you are increasing the potential. So you will always write that potential positive, and whenever you are going from positive to negative, always and always the potential will drop. That means we'll write it as negative. Okay, and for resistance specifically, remember, if this is the direction of current, the direction of current will tell you how and where positive and negative sign will come. So this will be positive, this will be negative. The current will always, whenever it will pass through a resistor, will drop the potential. Okay, cool. Okay, guys, now this one we have a junction being mentioned over here. Okay, as in not mentioned, but you can see it over here. Let's call this point as P, and question wants us to find out the value of the current that is passing through the 10 ohm resistor. So if I say that there is some I current that will go from 10 ohm resistor, it will split into two different currents, say I1 and I2. Okay, just my own visualization of the situation. We don't even know what will be the direction and value of the currents here. So what we are saying, suggesting here, that if current is going towards the right in this branch, and the point, if I name them as A, B, and C, so I am suggesting that current is going from A to P. That means potential of A is more than potential of P, and P potential is certainly unknown, so I'm calling it as potential X. Okay, and from P to B, current is going from P to B, so definitely the potential P, I'm assuming it is higher than 7 volts and higher than 5 volts as well. Okay, so we don't know what exactly is that. We don't even actually know about the I1 and I2 direction, and we are even assuming that X is going to be a potential less than P. So if we are going to find that out, if answer comes out to be positive, we are right. If answer comes out to be negative, we are wrong about it, or it's going to be just the opposite of it. Okay, so the method that we use here, I told you people, it's junction rule, which we are going to go with, but the name, the fancy name which is given to problem solving of this type is called nodal analysis. Okay, guys, so I will say that simply I will be equal to I1 plus I2 by junction rule, or KCL. So value of current I will write as 10 minus X, the potential difference, divided by the resistance, that is 10 also, right? and I1 will be equal to x minus 7 divided by the resistance, that is 20. So what I'm writing is I equal to V by R's. Okay. Similarly, this will be x minus 5 divided by 30. Okay guys, you can see that zeros are getting cancelled. So I have 10 minus x equal to, taking LCM, I will have 3x minus 21 plus 2x minus 10 divided by 6. So if I rearrange this part, it becomes 60 minus 6x equal to 5x minus 31. Okay, which tells me that 11x will be equal to 91, or x comes out to be 91 by 11. So even if the denominator I consider as 10, the value will come out to be 9.1 volt, but the denominator is even bigger than 10, so that means x value is definitely less than 10. So I'm very sure and very correct about the value of I, and it's not about the value but the direction. It's coming out to be the value of x coming out to be positive 91.11. Okay, that tells us that it's going to be somewhere 9 point some value. Okay, so now when I'm going to find out the value of I, it's going to be 10 minus 91 by 11 divided by the resistance, that is 10, which gives me the value 1 minus 9.1 by 11. So when you simplify this, I will come out to be 0.172 ampere. Okay, that means the answer will come out to be option B. Yes, definitely. I'm leaving the calculation for this part from here to here for you guys for this one step. The answer should come out to be 0.172, as answer is option B. Okay, cool. Okay guys, now this one, this says that we have to consider the circuit shown in the figure. The current I3 is going to be how much? So you can see that there are three batteries here. So definitely if I write the current which is starting from 12 volts battery to be I1, and say some current which is going to, if you see that already I3 and I1 are reaching here, so I'll have to send some current back here. So I'm assuming that I2 current will go from this junction. Let's call this junction as Q and this junction as P. So from Q, the current I2 is going to the battery, and obviously it will be the same current I2 which will come here. Okay, and if I1 has to go here out of I2, what you will be left here with, what you are going to leave here is I2 minus I1. So I3 is nothing but I2 minus I1 in short. Okay, cool. So let's go with the loops here. So if I consider this as A, this as B, this as C, and this as D, then in loop A, P, Q, B, A, if I go and say I'm going to go in clockwise sense. So I start from say P. If I start from P, I have a potential drop of 6 volts. Then I have a potential drop of 8 volts. Then I have a potential drop of minus 28 I2, and this should be equal to 0. So that tells me that 28 I2 is going to be equal to minus 14, or I2 comes out to be minus 14 by 28, or simply minus half of amperes. Okay, similarly if I go in the loop as say PQDCP, okay, PQDCP, that means I'm going to go in this one as anti-clockwise. So in this, if I go like that, I have from P to Q, I have potential drop of 6 volts, so minus 6. Then I have a potential drop of 12 volts, so that is minus 12. And then I have a potential increment of plus 54 I1 equal to 0. So I have 54 I1 equal to 18. Okay guys, that means I1 comes out to be 18 by 54, or simply 1 by 3 amperes. Okay guys, so I have the value of I1 as 1 by 3, I2 as minus half, and I have to find out I3, and I3 is nothing but I2 minus I1, which is minus 1 by 2 and minus of 1 by 3, which looks like it's going to be minus 3 minus 2 by 6, or simply minus 5 by 6 amperes, which tells us what? That the diagram itself, the direction which has been given here is not supposed to be this. Rather, the current in this branch from in P to Q, it's what is given is the direction P to Q. The current will actually flow from Q to P. So the answer as per the options is going to be option D. Okay, guys. Awesome. Okay, now this one, in this we have to find out the value of the current that is going in the upper branch, and with that I'm also calling the currents as, do I need to name them? Let's see if do I have to, but I'm very sure that whatever is the potential which will drop, say between P and Q, will be same for all of them. Okay, let's say that VPQ is equal to V. So I'll try to find that, and that is going to be equal to I into R equivalent. Okay, so let's try to find out R equivalent. So because all of them are connected, all the branches rather are connected in parallel, so I will have 1 by 60. The middle branch is 15 plus 5, that is 1 by 20, and the bottommost branch is 1 by 10. So it looks like LCM is going to be 60. For that it will be 1, it will be 3, and it will be 6. Yeah. Okay. So 1 by R equivalent will be equal to 10 by 60 or 1 by 6. That says us that R equivalent is coming out to be 6 ohms. Okay, guys, very simply. So now I can find out the value of VPQ, which comes out to be IR equivalent. So current that is reaching is 1 ampere, R equivalent is 6, that means it is 6 volts. So now I can find out the value of the current in that branch, the topmost branch, which is going to be V by R60. Okay, so that is 6 by 60, or simply 1 by 10, or 0.1 ampere. Okay, so what did I do? I first found the value of all the equivalent resistances. All the value of resistances were used to find out the R equivalent. Then we knew that whatever potential drop is happening on R equivalent will happen on all the branches. So I got the value of the potential drop on the equivalent circuit and also on 60 ohm resistance. So V equal to IR, I value came out to be V by R60. Okay, cool. Okay, guys, now this says that in the above circuit we have to find out the current in each resistance, which means simply the current is going to be same looking at the options. So let's have a look at this first loop here, guys. Let's call it loop number 1. What you see here that both the batteries are opposing each other, and if I consider some I1 current is flowing here, what will I say? It is 2 minus 2, say plus I into R1, and this should be equal to 0. It tells us what? That IR1 will come out to be 0, and that is only possible to be 0 when you have, sorry, I1 R1, right? So the value of I1 R1 will be 0 only when I1 is equal to 0, which means what? In this branch the current is 0, then definitely in all the branches it has to be 0. But if you want, you can try the second loop as well. There also you can see that the polarities are different for the battery, so it will be 2 minus 2 plus I1 R1. We don't know, the other one could be say minus I2 R2, if I call it I2, right? So again this values will be 0 and they will come out to be equal, which is nothing but 0. So all in all we can say that the value of the potential, sorry, value of the current in all the resistances is going to be 0, as simple as that. Okay, cool. Now this one, guys, this question says that already some current values are given, that I1 is given to us as minus 0.3 ampere. We have been given I4 as 0.8 amperes, and I5 is given to us as 0.4. Okay, so what you see here are the junctions, and the value of I2, I6 and I3 are to be found. So if you look at this junction S, already zero point 0.8 is coming and I3 is going from here. So out of 0.8, if 0.4 has gone, so it has to be 0.4 ampere. So what I see here, that I3 is coming out to be 0.4 amperes. Okay. Also, if you look at this branch S to P, P to Q, the same current has to pass through. So definitely the value of I6 is going to be equal to I5, and that is equal to zero point 0.4 ampere only. Okay, so I6 and I5 values are coming out to be same. Now what I'm left with is I2, and for I2 let's look at junction R. So already I1 current is approaching and I4 is going. So I can say that I2 will be equal to I4 minus I1, which is 0.8, and minus minus plus 0.3, that comes out to be 1.1 ampere. Okay, so the value of I2 comes out to be 1.1, I3 is 0.4, I6 is zero point 0.4. So looking at it, yes, either A or B is supposed to be the answer, but here one of the current is given negative, so definitely answer is option B, with this as I2, this as I3, and this as I6. Okay guys, easy, simple application of KCL. Okay, now this one, here we have a part of the circuit being given in the figure, and the potential difference between point G and point H is to be found. Okay, now what you see here, from G we have a 2 ampere current flowing down. Okay, and definitely the same current is passing here. Okay, so it's 2 ampere current that reaches this junction. Let's call this junction as P, and at junction P I have 2 ampere current reaching in. But if I look at this junction Q, I can see that 1 ampere has gone up and 3 ampere has gone down. That simply means both of them are outgoing, so there has to be some incoming current of 4 ampere. So from here a 4 ampere current has to go from point P. So point P already has 2 ampere current reaching, so furthermore 2 ampere current is supposed to go from H to P. Okay, so definitely the polarities can be understood. Okay, so now we'll start from G to go to H. So I have all the currents in the branch here. So from G, when I start moving, I have a potential drop of minus 2 into 4. Then I have a potential increment of 3 volts. Then I have a potential drop further of 2 into 2 amperes, 2 into 2 volts. And then I reach P, and then I go from minus to plus, which is a potential increment of 2 into 1. Like that I reach potential of H. Okay, so this is Vg minus 8 plus 3 minus 4 plus 2 equal to Vh, which says that Vg minus 12 plus 5 equal to Vh, or Vg minus Vh comes out to be, this is minus 12 plus 7, minus 12 plus 5, which is minus 7, goes on the right side. I have plus 7 volts, which means answer is option C. Okay, so we were concerned about only this branch from G to P to H. Okay, so answer comes out to be option 7. Okay guys, now for those who are new on the channel and want to know how can you cover up the topics which I have done before this, obviously there are many topics which we have already completed. uh, already electrostatics, Gauss's law, capacitance, and a lot of current electricity is being covered here. So if you are interested in covering up all that, then all you have to do is go on the channel playlist, and in the channel playlist what you have to look for is this playlist which says JEEt Lo 2021. That is for standard 12. Okay, cool. I hope that's understandable and easily accessible to all of you. Also guys, if you are interested in joining a crash course, especially for students who are aspiring for JEE 2020. So guys, this is the last crash course batch which has begun on 15th of June. Okay, it's still not very late. You can still cover up a lot of good portion with us. For that, all you have to do is go on a link that I'm going to share with you all. Let me tell you what you're going to get in this crash course. You are getting 90 plus live classroom sessions with the master teachers, a lot of tests as your test series part. You have your own performance analysis being shared from our end. You get rank booster quizzes during the lectures and a lot of things in addition to what you are getting as point number 1, 2, 3, 4. Okay, so guys, this batch as I said has begun already on 15th of June, and if you are interested in that, all you have to do is go on this link which is available in the description box, and don't forget to use the coupon code, that is SMCC. And if you do that, the course which is worth rupees almost 25,000 could be yours. Okay, could be yours for just under 4,000 rupees. Okay. Also, if you are interested in joining just a test series where we are giving away 10 full length tests, live discussion of all the tests that you will be appearing for, and unlimited doubt solving. Okay, so this is also just now started. Okay, this is 22nd of June, the beginning date. So you are still very much in sync with this test series. If you are interested in joining this test series, guys, all you have to do is go on this link, which is also available in the description box of this video, and use the coupon code SMTEST, because if you do so, the crash course, the test series, which is worth rupees almost 10,000, could be yours for 1399. Okay, remember, test series is starting from today itself. It is 22nd of June 2020. Okay, cool guys, I hope it's understandable to everyone. If you are interested in joining our Telegram group, by the way, we have a Telegram group as well where we share assignment solutions, study material, and daily updates. And that link is also available in the description box of this video, so you can be a part of that as well. Okay, awesome, cool guys. So I hope you guys enjoyed solving questions of Kirchhoff's laws with me today, and if you did, then I would want you people to press that like button. Also, tell your friends about all these lectures. If you are benefiting out of it, let them also take advantage. And if you have not, then do subscribe to the channel right now and press the bell icon so that whenever your Suri Sir comes live, you will be notified. Okay, guys. So, with a mission that we are going to crack JEE 2020 or 2021 or 2022, doesn't matter whether lockdown is there or not, we will ensure that your learning won't stop. Okay, guys. So, with that promise, I'll take your leave. I'll see you very soon. Till then, take care. Bye bye.